Alright, ladies and gents, today we're going to talk about the rational zero theorem. Basically what this theorem is telling us is it's giving us a set of numbers that are possible factors of a polynomial. So before, I gave you a polynomial and one factor, and I asked us to factor the rest of the polynomial from that point. Now we're going to factor it without knowing any of the factors, and we're going to start from pretty much level 0. Basically, if a factor is not given, it can be found by the set of numbers formed by dividing the factors of the constant term and the factors of the leading coefficient. Okay, this 7 is our constant, and this 5 is our leading coefficient. So our possible zeros, or possible factors, remember, zeros is where the function crosses the x-axis, and our factors tell us that. Are going to be factors of 7 are 7 and 1. Factors of 5 are 5 and 1. Okay, so I'm going to set up fractions with those possibilities. So we got 7 over 5 and 7 over 1. We also have 1 over 5 and 1 over 1. So our possible zeros are 7/5, 7, 1/5, or 1. And also, we need to think of the negatives and positives, because positive 1 times positive 7 is a positive 7, and a negative 1 times a negative 7 is a positive 7. So all these are going to be plus minus. Alright, so one of our factors is in this set somewhere. So we just got to pick one, do synthetic division, and see if it works out. So just for argument's sake, I'm going to start with, I'm going to say 1. So right now I'm just going to test the zeros. And remember, if our remainder is 0, that means it is a factor. So I'm just going to test 1 first, because 1 is just an easy number. So we got our coefficients 5, 46, 84, negative 50, and 7. Okay. So 1 is a factor. So that means we can write this as x minus 1. And then this is going to be our new polynomial. 5x to the third minus 41x squared plus 43 minus 7. Now we can still factor this. I'm still going to try and factor this. Now our zeros are still going to come from this set. So I'm just going to pick, I can pick 1 again, but just for keeping it interesting, I'm going to pick 7. Just because that's our other whole number. I like to stay with the nice numbers before I get to the fractions. Now I'm going to use these numbers instead of these numbers. So we got 5, negative 41, 43, negative 7. Oh, well, this is working out nice. It's not always going to be perfect, but sometimes you'll get a remainder that's not 0, and you just have to pick a different number. Okay, so now we have our new factored version is going to be x minus 1 times x minus 7 times this new polynomial. And that is a quadratic. This is a quadratic, so that can be some. What am I trying to say? That can be factored. Let me make that a little smaller. So we have x minus 1, x minus 7, factors of 5 that multiply to 5, and factors of 1, bump, bump. They multiply to a positive and add to a negative, so they're both going to be negative. And there we go. Now it's completely factored. Okay. When we get to class, we'll do a lot more practices with this because it is a skill that gets better with time, and there's so many variations to each problem. All right. Have a nice weekend.